Hey, chemistry class. How's it going? Yeah, Yolieli's and Leilani. I thought I'd make a video for you guys because I wish we had class. It's really a bummer that we don't. But I thought I'd try to make, I'll make videos every week to try to help. I don't know. I mean, chemistry is important, and I think you guys haven't really got a fair share of chemistry for having taken the class for a year. So I'll try to make up for some of that. And I'm not going to try to cover things really in-depth detail. I'll just try to cover some important points that I think are important and that are important for your basic understanding of chemistry. So in the future, when you have other classes, you can know just some of this basic stuff in case you would decide to go into medical field or any type of sciences, or just for your camp maybe this summer, Leilani. So yeah. So today's lesson, okay, is defining the atom. And so I sent out on EduSystem the defining the atom lesson. So hopefully you take a look at that. I'm not going to make these videos too long, okay? I'm just going to talk about some things to hopefully reinforce what you learn on EduSystem, okay? So check out the EduSystem. You can either watch this video before or after, and then I'll assign some questions at the end. And that's the plan for this video, okay? Here we go. It's hard to see the board, but you see that? Okay. So today's lesson, today's actually the 9th. So guess what? I made one of these yesterday, but it was too long and I couldn't upload it because our internet's too slow and because it wouldn't let me verify my account. Let's adjust this so you can see me. I'm kind of tall. Okay, today's the 9th. Happy 9th of April. Hope you guys are staying safe in quarantine. I also made a video for conversational English if you guys want to check that out. But here we go. So today's lesson is defining the atom. This hopefully is some review that you guys already know. And if it's not, then I'm just going to try to go slow so you can just pick up some key things. Okay? So what is an atom? I can't hear you guys respond, but I'll still ask, okay? Respond in your head or out loud at home, okay? The smallest particle of an element that maintains its properties. So if you broke, gold is an element, right? You break it up, the smallest particle it can be, where every part is, it's still gold, that is an atom, okay? So we're gonna go over the history of the atom and how they discovered the different parts inside the atom, and the different people that did that, okay? So the first big experiment. So after the atom gets discovered, we're kind of just hopping right in there, okay? So the cathode ray experiment is how they discovered electrons. And a cathode ray is actually what old TVs used to be made of. Big, those big, thick TVs that maybe you still see at some old restaurants or something. That's a cathode ray. And the way a cathode ray works, okay, don't worry too much. I don't know if you can see this. But the cathode is the negative end. There's a negative end to the ray and a positive end to the ray, okay? And you have the anode, which is positive, and the cathode, which is negative. You think cats are negative, they're not very happy sometimes. The anode is positive, okay? And the way it works is they put electricity through the cathode ray, and it flows from the negative to the positive end. And I'm not going to go into detail about this, but the main idea is they use this cathode ray, put electricity through it, they changed the properties, and they found that there's a negative particle that consistently flows from negative to positive. And that they discovered these. But they didn't know, they called them electrons, but they didn't know how big they were or if they were a type of atom or a part of an atom. They didn't know, okay? But that's the thing. Cathode ray experiment discovered electrons, which are the negative parts inside the atom, we know now. Okay? That's first. Then we had J.J. Thomson come along. Okay? There, I got some notes. I got my notes, so I don't, skip things or go too fast or get ahead of myself. Okay? So after the cathode ray experiment, J.J. Thomson, he figured out the charge to mass ratio, which you don't have to worry. It says, everything I'm saying, it says with more words in EduSystem. But I'm hopefully just trying to give you a course so you can slow it down and take a deep breath, and it makes a little bit of sense, okay? So he was in the late 1890s, and Basically, he figured out that electrons are part inside the atom, okay? You have electrons inside, and he came up with this model called the plum pudding model. Can you see that? The plum pudding model, okay? And the plum pudding model, think of it as coconut pieces inside tembleque. And the coconut pieces are electrons. You have these electrons in the tembleque and they're just all over the place. Can you see this? There's just electrons, boom, 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 all over inside. Like there's nothing about protons or neutrons, nothing positive, just only electrons floating around in the atom. That was his theory, okay? And the thing is, his theory was not well accepted because everyone was like, no, we already know about atoms. We know what atoms are. Like, we know there's not electrons inside. We just know. And it's just one of those things where he actually was right. There are electrons. But other people didn't believe him right away. And it'd be kind of like one of those big discoveries nowadays. Or like if someone was to say, oh, when you breathe, your lungs don't actually need... Your lungs don't use oxygen. They actually use nitrogen. For example, right? We know we need oxygen to survive. But if someone were to come up with a big discovery like that we actually use nitrogen instead of oxygen, everyone would argue and be like, no, we know that we need oxygen to survive. So it's like, that's kind of how it was. So he actually was right. He was like, yes, there are electrons and electrons are real, but not everyone believed it because it's hard to change everyone's mind. You know, so there's a new idea. It takes a while for it to warm up. People to warm up to the idea. Okay? So, yep. So now we have the plum pudding model. Alright. Let's turn you over here. Oh yeah, you can see. Okay. Perfect. I know my marker is not very good, so it's hard to see the board. Everything on the board though is also at home on your end system. Okay? So I just wrote this up here more to help me, I guess, and hopefully to help you guys. But so the next thing that happened is Robert Millikan. And all you need to know about Robert Millikan, he did this thing called the oil drop experiment. And what the oil drop experiment was it's like you have oil up above and a little tiny slit, and the oil comes dripping through. And they had like an electric, I'm really condensing this, but they had an electric field, and basically by dropping the oil through the slit and having the electric field, they figured out the mass of an electron. So how much the electron, it's mass. And you know about mass. Mass is different than weight. Mass is the same everywhere. Weight depends on gravity, right? But they figured out the mass of an electron. And that's important because they knew that it's really small. It's way smaller than an atom, okay? That's all we'll say about Millikan. But he discovered the mass, calculated the mass of an electron. And if you want the exact number, it's an edit system. But for now, like with this crash course of a month chemistry, you don't have to memorize that because we're not going to have exams. This is all just for your own knowledge, okay? Next is Ernest Rutherford, which I think you guys learned about in your other class. But he did the gold foil experiment, okay? Gold foil experiment, and that was where you had this piece of gold foil here, and you had this particle shooter. It shot positive alpha particles at the foil. And the hypothesis was that when he shoots the particles, they'll go through the foil, or maybe get turned a little bit because they hit electrons, go a little bit and turn a little bit, but that they'll go through. But what ended up happening is he shot these positive alpha particles at the foil, and some went through, and some went kind of like to the left or the right, and then some came directly back at him, which was crazy. He describes it in his own words. It was like if you shot some type of gun at a piece of tissue paper, right? You know a gun would just go straight through tissue paper. If you shot it and it came back. So that was really crazy. And he was like, wow, there is something in an atom that is really hard and really dense that is causing these things to bounce back. And he figured out it was a proton. And part of that is because opposite charges repel. Like charges repel, opposite charges attract. Okay? So the center of the atom was positive, and he was shooting particles that were positive, and then they don't want to touch, so they go boom, and they repel. Okay? So that's how we figured out that there's a nucleus, basically. Let me make sure I didn't miss anything with that. Yeah, pretty much. That experiment was where they discovered the nucleus, but they didn't know there was different parts. They just thought the nucleus was positive. Okay? So that is where they discovered the nucleus and protons. Like there's a positive nucleus with negative electrons around it. Okay? To bring up the last big point, James Chadwick, we won't talk about his experiments, but he actually got a Nobel Prize. When was that? He got the Nobel Prize in 1935, so not that long ago, less than 100 years, right? Because he discovered neutrons. So what happens is, the way the atom works is there's, in the center, there's protons and neutrons, and the electrons are moving all around the protons and the neutrons, okay, in a cloud. And it's called an electron cloud, because we don't know where they are. They don't just go in circles, they're going actually crazy orbital patterns, like dumbbell figure 8 shapes. Okay? I'm sorry, you can watch this video over and over if I'm talking too fast. I'm just trying to not make a super long video, because then I have to upload different ones, okay? So, the way this works, and it gives long videos, I lose your attention. So the way it works, so Chadwick discovered the neutrons. So the nucleus has protons and neutrons, and they each weigh the same, okay? And the big key with atoms are neutral. So atoms have the same number of protons and electrons, which makes their charge, so if you have 2 protons, there's also 2 electrons, and its charge is neutral. Now, there are types of atoms that are called ions that have charges, but those are ions, they're different than atoms. So something called an atom has a charge neutral, charge of 0, because it has however many protons, maybe 3 protons, 3 electrons, okay? Neutrons weigh the same, but it doesn't have to have the same number of neutrons as it does electrons. You can have different isotopes that have different weights with different neutrons, but don't worry about that. The thing you need to know, protons and neutrons, same size. Protons and electrons cancel each other out. Positive, negative. Okay? Well, the other big key, the nucleus contains 99.97% of the atom's mass. So that's like pretty much, in the center, there's this little tiny nucleus that's really heavy and dense. And then the rest of the atom just has almost nothing there. Just these little electrons moving around that weigh almost nothing. Okay? So to recap, right, we had the atom, they ran the cathode ray experiment, passed the charge from negative to positive, figured out, oh, there's a negative particle called an electron. Okay? From there, Thomson figured out electrons are smaller and they're inside the atom, and he came up with the plum pudding model, which is like tembleque, pieces of coconut floating around in the tembleque. Okay? From there we had Millikan with the oil drop experiment. Okay? He figured out how heavy an electron is. Okay? So that's good, we know they're very small. Then Rutherford, the gold foil experiment, he shot the alpha particles at the gold foil, and some came back, right? Figured out there's a very dense nucleus at the center, and it's positive. And then to bring it all home, well, there's a lot more, but up to this point, Chadwick figured out there's neutrons. So what do we know? The center of an atom has the protons and the neutrons. It's called the nucleus, right? Almost all the mass, over 99% of the mass is there. The electrons are in a cloud around the nucleus, okay? That's all I got for today's video. I'm praying for you guys. Stay safe. Hopefully this video helped. Email me. I think you guys will have my email, because I'm going to email you this video. If you have questions, email me, okay? The last thing I want to do is assign. I want you to do all the questions in the defining the atom review, except question 11. So I think the questions go like 7 to 10, because there's no number 1, but do all of them except number 11. And if you have questions, let me know. Next week when I make the video, I'll go over that, okay? Alright, miss you guys, wish you had class, but hopefully this was almost as good. And until next week, see you next week.